Alright, so this is supposed to be 8C video, but we're going to start off with 8B. There is a formula that I left out, sorry. If you don't have the summation key on your calculator, you get to that as well. There is another way to do it with this formula. This formula is given to you on the S12 sheet, formula sheet. But what we have to do is we have to find the number of terms. So the number of terms with the summation was down below is your first term. So we're going to start with term number 5. We're going to end up with term number 10. So 5, 6, 7, 8, 9, 10. There are 1, 2, 3, 4, 5, 6 terms. And this is also the number of terms. 0 is your n. No first term. First term, we're starting with term number 5. So we put 5 in for above. Using the formula 20 minus n. Using this formula, substitute in 5 for n. Oh my gosh, 5 is 15. So that's your first term. And the last term of your sum is, we're going to end up with term number 10. So we put 10 in for n. 20 minus 10. The last term is going to be 10. Then we have to evaluate the series, which means add it up. What we're going to do is use this formula over here, S sub n. So let's use this formula. So S just means you're summing it up. So we're summing up. N means the number of terms, so we're summing up 6 terms. And it's going to be equal to, n again is 6 divided by 2. Times in parentheses, the first term of our sequence, the value is 15. And the value of the last term of the sequence is 10. If we sum this up, 6 divided by 2 is 3, 25. The sum of the first 6 terms in this series is 75. So you add them up, it'll be 75. One other quick thing is tell whether each list is a sequence or a series. The sequences are numbers, commas, series, adding. So hopefully we can tell. So the sequence is right here. The series are with addition. And then tell whether it is finite or infinite. Finite means it ends. Infinite means it goes on forever and ever. So let's look. What's finite? Finite. So finite ones will put in blue. It's ending. That doesn't have a dot, dot, dot at the end. Down here, no dot, dot, dot at the end. So that is finite. And infinite goes on and on and on. So dot, dot, dot. Infinite, dot, dot, dot. Dot, dot, dot. Infinite. So that's just a quick little exercise. All right, now let's get to 8C. 8C is infinite geometric series. We have to decide whether each infinite geometric series diverges or converges. If it diverges, it's going away from. It's going to diverge towards infinity, so the numbers are going to add up towards infinity, to infinity. If it converges, you're converging, like if you converge, you're converging on something. So when you're adding this up, it's going to add up towards a number. It's going to get really, really close to a number. So we have to state whether each series diverges or converges. So what you do is we have to find that it's all based on the R value, the common ratio. Since it's geometric, we're talking common ratio. So what you do is the second term divided by the first term. And that's just 1/5. So the ratio is 1/5 on the first one. And I guess I should probably mention that if the R value is the absolute value of R is less than 1, it converges. If the R, the common ratio, the absolute value of it is greater than 1, it diverges. So in this case, absolute value of 1/5, absolute value of 1/5, well, that's 1/5. And it certainly is less than 1. So therefore, it converges. It converges if we add up 1 plus 1/5 plus 1/25 plus the next one, I believe, is 1 over 125, and then it's 1 over 625. If you add all that up, it will converge to a number. It will add up to a number. Even though it goes on and on forever, it'll add up to a number. On the right side here, we have find the common ratio. Second term divided by first term is 2. Well, the absolute value of 2 is 2. And last time I checked, 2 is greater than 1. So that means it diverges, which it diverges away to infinity. So it diverges to infinity. So, I mean, you think about it. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus, it keeps on going on forever and ever. Those numbers keep on getting bigger and bigger and bigger. It'll never add to anything. So it really diverges to infinity. Where if you're adding a smaller number over here, it'll eventually, the numbers are so small that it really doesn't even matter what you're adding. They're so tiny numbers. So therefore, it will converge to a number. And the next part will actually converge to a number. So here we are, evaluating each infinite geometric series. On the right here is actually our formula we're going to use. So it's S sub infinity. Infinity means that it goes on forever and ever. That's the dot, dot, dot here. That's infinity. So anytime you see infinity and it's a geometric series, we have to use, to find the sum, we have to use this formula. So in this formula, you have a sub 1, which is your first term. So that's 1. We have the R. Well, the R value is, that's just taking the first or second term divided by the first, which in this case is negative 1/5. And on the right side, it tells us absolute value of R is less than 1. Well, absolute value of negative 1/5, how far is that away from 0? That's 1/5 away from it. So the absolute value of that is certainly 1/5 is less than 1. So therefore that tells us we can use this formula. So yes, we can use the formula. So we have S, the sum of this infinite series is going to equal the first term, 1, divided by parentheses 1 minus R, which is 1/5. And I will magically have a calculator that appears in this. Ta-da! There's a calculator. I put it into the calculator, put parentheses around the denominator and the fraction. And I get 1.25. I don't like decimals, so let's change that to a fraction. So math, frac, 5/4. So that sounds weird that you can add up an infinite series of numbers, and it'll add up to a number. It adds up, in this case, to 5/4. Sounds weird, but it can happen. Come to class ready for a possible quiz on this example or one of the other examples. And if you have any questions, if you want to do the rest of the worksheet, the classwork, you're more than welcome to, and then you can do all retakes next class. Enjoy.